Sir, Santanu sir, Mehboob sir, and all the participants. Myself, Sanchita Ghosh, Assistant Professor of CAC Department of Bengal College of Engineering and Technology, Durgapur. We conduct here 5 days STTP International Short Term Training Program, and today is the first session of our last day. STTPs are going on the topic of machine learning and data science marvels. This session is chaired by Mr. Mehboob Rahman Mandal sir, Assistant Professor of CSE Department of Bengal College of Engineering and Technology. Today our honorable speaker is Professor Dr. Jyotsna Kumar Mondol. I welcome you sir. So there is lot of things to say about him, but today I will give a short introduction of him. Presently, he is working as Vice Chancellor of Raiganj University and former Dean and Faculty of Engineering and Technology and
A
Management.
little correction. I was. Now I am in Colon University. So my
Okay,
term
okay,
has
sir.
ended. Okay.
Okay, okay, sir. He is a professor of department in CS of CSE in Kalyani University, West Bengal. Uh, he started his career as a lecturer at NERIST Arunachal Pradesh in September 1988. He has teaching and research experience of 35 years. His area of research is coding theory, data and network security, image processing, remote sensing, and GI-based application, data compression, error correction, visual cryptography, and steganography. He has produced 29 PhD degrees. He has published more than 450 papers in various international journals and conferences, out of which is 185 papers in international journals, 45 papers published in SCI journals in the last 5 years, with highest impact factor 7.980. He has got many awards and honors. One of them is Shiksha Ratna Award 2018, Department of Higher Education, Government of West Bengal, and also Rashtriya Pratibha Award 2017, Indo Socio Development Association, Delhi. This session is live on our YouTube channel, and all the participants are joined there, and they will ask question on the chat box. Our session chair will collect all the questions and ask to the speaker at the end of the session. Thank you. Now I am requesting sir, please take over this session. Thank you so much.
Okay. Thank you for your nice introduction. So I'm just sharing my screen.
Okay sir, thank you sir.
So screen is visible. Screen is visible.
Yes sir, screen is visible.
Okay.
Yes sir.
Fine.
Okay sir.
Thank you. So on my today's talk, we are going to have some idea of latest technologies and trends in security and authentication in image communications and signal processing. So my details already discussed. So we are talking about the communication. So when I am talking about the communication systems, that means why security comes. So in communication systems, you see that we are sending some information, and that information is not directly reach to the receiver. Instead of that, it is reached to the receiver in terms of some hop networks. That means X is sending to Y. So in between there are multiple hop communications. So this is causing a problem that you see some intermediate node may be a legitimate node or may be a malicious node that cannot be controlled by your source or destination. So the system is that we have to provide some security in communication systems for that particular reason. So this is the main domain of the problem. And in this domain, we are addressing two issues mostly. One is your cryptography, another one is your steganography. So already you have discussed. So you see that when data is being flown from source to destination in multi-hop network, so you see there may be eavesdropper or spy which cause the problem, and this is our problem domain. So for that, we are addressing by using the encryption at the source end, and we are sending the enveloped data through the communication channel to the receiver. And you see that ciphertext, which is called the ciphertext, and that is being decrypted in terms of some algorithm, and that is called the cryptographic system. And that is a problem for the intruder. But you see, there is a simple consequence that when I am concealing my information and I'm sending the enveloped information instead of source information, in that case, you see that we are using some keys, maybe single key or maybe multiple key. So my lecture is oriented towards the aid to how to reduce the key exchange. And one of the major concern is that is to go for a key exchange methodology, that prior to the transmission of the information, exchange of the key you have to throw, and man in the middle can intercept the key anytime. If keys are intercepted, the algorithms are most of the cases mostly known, and the data will be again recaptured by the intruder. So that is the problem of exchanging the key, which is a famous terms we used to say that this is a Diffie-Hellman key exchange technique. So that means, you see, can we not reduce this key exchange or eliminate this key exchange? So if I can eliminate, so towards the end I will give some glimpse of that, how for eliminating the exchange of the keys. But you see here, you see when during the key exchange, your man in the middle uh, attack is always there. You see, I'm not going to details. So now, when we are talking about the security aspects, we have two security aspects. One is called the cryptographic aspects, and other one is called the steganographic aspects. So in cryptographic aspect of communication, secured communication or security in communications, what we used to do, we used to go for some generation of some key, maybe a single key, maybe a multiple set of a multiple key, and we used to scramble the information. Just in your mela you have seen that data is that you have a circular disk, numbers are there, and based on the number some items are there, some items are valuable, some items are not valuable, very less value, suppose matchbox or a single candles stick. But when you are rotating the fulcrum, rotating the rotor, so you see that it is absolutely biased. It never come to the valuable goods in number. So, because you see that the fulcrum is not absolutely unbiased. Inside there is a biasness. It has been prepared in that way that when it is rotating in terms of the on the base of the fulcrum, it is a bias system. So but here cryptographic systems, we are trying to remove the biasness at any cost. And you see what we are talking about, that we are talking about the exchange of key and sharing of key. Now I am talking about two terms. One is we are talking about the exchange of a key, And another one is we are talking about the sharing of key. Normally there are two types of cryptographic system. One is called the symmetric cryptography system, and another one is called the asymmetric cryptography or public key cryptographic system. So in asymmetric cryptography system, we have a pair of key, and we used to exchange that pair of key prior to the transmission of my information. But in case of symmetric key cryptographic system, the key is shared. And algorithm for encryption and the algorithm for decryption both are using the same algorithm. That means the identical algorithm in symmetric crypto system. But in asymmetric crypto system, asymmetric crypto system sorry, consisting of a pair of key. One is called the public key and other is called the private key. And so you see, when I am talking about the exchanging of the key, prior to that we have to exchange of that key, and then you are sending the encrypted information. You see that we normally in a public key cryptography, we encrypt with a private key and we decrypt with a public key. And keys are not merely transmitted, it is an exchange process which is called the Diffie-Hellman. Normally it is called the Diffie-Hellman key exchange procedure. So using this Diffie-Hellman key exchange procedure, we used to generate the key pair at both end of the communication. That is a mathematical computations and considerations for this key exchange technique. So what is the problem in Diffie-Hellman key exchange technique? That it suffers from man in the middle attack. So if we say about the formal definition of a crypto system, a crypto system has a five tuple where P is the finite set of possible plain text, C is the finite set of possible ciphertext, K is the key space, is a finite set of possible keys, and for each key belongs to K, there exist an encryption rules. EK belongs to E and a corresponding decryption rules DK belongs to D. So if a plaintext is encrypted using EK, the resulting ciphertext is subsequently decrypted using DK. That means it is a complete reversible process. The process is completely reversible one. And you see that if I am talking about the symmetric key crypto system, then keys are transmitted over a communication channel which may be a private channel or secured channel, and it is not embedded into the encrypted text. Rather, we used to send the key separately in terms of some other communication system. So there are two requirements for the secured use of secret key crypto system. What are these two? The first thing is that a strong encryption algorithm is needed. You have to generate a strong encryption algorithm, and the sender and the receiver must have obtained the copies of secret key in a secured fashion. That means you have to keep the key secured. So you see that here, you see this is a private channel. I'm sending the keys through this private channel. Here, this one. So now the crypto system generally characterized by three independent dimensions. One is type of operations you are using for transforming the plain text into the ciphertext. That means what are the operations? Normally we use two types of operation. One is called the substitution operation, and you see another one is called the permutative operation. That means, and that's why you see in lot of books and the literature you will see that it is p box and s box operations. So whatever methodology, whatever algorithm you are using, it is consisting of P box and A box. What are the combinations and what are the substitution methodology, that depending on your algorithm. But particularly when you are talking about the operations in your cryptographic system, that means it is transforming by using your uh, substitution and permutation. And secondly, some may use a single key crypto system, some may use multiple key, some may use the three-way key exchange techniques, three key use. So number of keys we are using. So in a symmetric key crypto systems, we are using a single key. In a public key crypto systems, we are using at least a pair of key. And the third most important thing is that what is the way in which the plain text is processed. That means I can consider that my chunk of source information into multiple block. Suppose 8-bit block, 16-bit block, 32 bits block, 64-bit block. That means a chunk of input information is taken, which is called the size of the block, and this cipher, normally it is called the block cipher. And another one is called the stream cipher. That means the I have a communication channel, the data is coming as a stream, or binary bits are coming as a stream. So this stream is being again encrypted. That is your stream cipher. Continuously when it is coming, it's a stream. So now in terms of the attack, you see there are two types of attack. One is called the cryptanalysis, and other one is called the brute force attack. First, let's consider the cryptanalysis. What is the cryptanalysis? You see that on the nature of the algorithm and some knowledge of general characteristics of the plain text, we used to go for an attack. Suppose, what is the example? If I give one example, it will be good for you. Suppose I am using an encryption techniques. What is my encryption technique? The encryption technique is that I am writing A, and in encryption I am writing D. That means B, C, D. When I am using A, it is D. When I am using B, it is E. When I am using C, it is A. You see that there is a shift A to D, B, C, D. That means three character shifts. Now I have encrypted the text. Okay, the text has intercepted by the intruder. So how intruder will see? Now intruder will go for frequency distribution analysis. What is the frequency? The number of A's, number of character. Then it will put a frequency distribution graph. So you see that my system was a homogeneous system. My system was a homogeneous system, that I have given a three character shift only. So if I draw the graph will be nature of the same. So intruder try to visualize in terms of permutation and combination. First, you will take that on the frequency distribution plus 1, on the frequency distribution minus 1, and generate the frequency. On the frequency distribution plus 2, minus 2, plus 3, minus 3. You see, in plus 3, both of the frequency distribution will be identical, because your encryption methodology has used the 3 bits, 3 character shift or 3 alphabet shift of the algorithm. Then it will take the frequency of the characters and it will go for permutation and combination to regenerate the meaningful text, because the notion of the text normally understood or guessed by the intruder. So you see, I did not go to the algorithm directly. I have gone for some mathematical analysis, or rather, I can say that I have gone for some statistical analysis. So, this is called the cryptanalysis. That means a strong mathematical foundation is there for the crypto analysis. It is not that breaking the code or breaking the algorithm. So this is very important factor. We normally misunderstand this cryptanalysis term. And the second thing is that your brute force attack. You see that when I am talking about a brute force attack, what is that? It attacks the key, try to break the key. And for what? For that, it goes for exhaustive search. That means I am taking single bit key, single digit key, 2 digit key, 3 digit key. So I am generating permutation and combination, and I am going for generating the key and try to just break the code. That is your brute force attack. So now in research fields of the cryptography, continuously the algorithms are being developed. So when an encryption algorithm is computationally secured, normally two characteristics are there. Normally, the cost of breaking the cipher exceeds the value of the encrypted information, and the time required to break the cipher exceeds the useful time. Suppose someone saying that I will blast place X at 5 p.m. So if I get the information before that, I can mitigate the situation. But after 5, no use. So that is the time required to break the cipher. And you see that normally we use a length of the keys. So the length of the keys, normally we are using 128-bit key. You see that RSA days, when it has been generated or developed at the beginning, it was a 64-bit key, but it was broken within 1 year. Now still you see that this is one table. I think it is mostly from the Starling's book. You see that it depends on the computing power of your system, and you see that how much time is needed. That means you see that how much time your system is exposed to the open space. Intruder will try for that. Suppose throughout the night your Wi-Fi is on. So intruder will try throughout the night for from his computer to break your code. Suppose you have switched off at 11 p.m. and you were switched on at morning 6 a.m. That means it's not getting much more time. That is, but it depends on your use and utility. I cannot say that you switch off anytime. Now, That is why the length of the key, when most of the cases you are giving the passwords, that one character, your name, your surname, so that is not useful at all. So you have to give some special character, extended character, and you have to use. That's why you see nowadays when you are creating the password for any credential of any web access, they used to say that it must be at least 10 character, 12 character, one alphabet, you see capital letter, one extra character for special character you have to use. So these are the some just to increase the strength of the key. Now, when we are giving all these things, your cipher technology is good. You have got a large block length. You have used a large key space. Still, you see, there is a problem in your block cipher mode, particularly in case of block cipher. What is the problem? You see that whatever be the algorithm, if input is XYZ and output is PQR, anywhere on your text, if there is a block length of 3 and XYZ is there, so PQR output will be there. That means for same input, output will be same. That means for identical input of your system, identical output will be there in a cipher based system. So what is the problem for that? The problem is that it normally suffers from cryptanalysis attack. That means it is called the string matching attack. So I will compute the matched string throughout the text, and I'll see that maximum number of same input give maximum number of same output. So same output, same length, same output, same length. So I can find out the length of the key. So that is one major problem in block cipher techniques. So to overcome this problem, normally we never go for straightway encrypting the plain text using direct key. We used to go use some mechanism. What are the mechanism? It is called the block ciphering, blockchaining of the ciphering. There are four systems. One is electronic codebook, second one is cipher blockchaining, third one is cipher feedback, and fourth one is output feedback, OFB. That means ECB, CBC, CFB, and OFB. It is your codebook that you have a plain text, and then you have a key. You are encrypting using the plain text, using the key, and you are getting the output. Again, plain text, key, output. Plain text, key, output. Now, are all these keys are identical? If all these keys are identical, then if the plain text are identical, output will be identical. That means it's suffering from your string matching algorithm. That means cryptanalytic algorithm. So that's why you use separate key or key transformation or key shifting. Lot of various algorithms are available for that particular purpose. Second one is your cipher blockchaining mode. How cipher blockchaining works? The cipher blockchaining works, you see that you have a plain text. This is your plain text, and you are taking some random number, which is called the initialization vector IV. So your plain text is executed with the IV. What is your operation? Maybe exclusive or operation, or maybe some other operation. I am not prescribing any operations. So it depends on the generation of your algorithm and intention of the developer of the algorithm. Then the output of IV and plain text is made input to the key and your encryption algorithm, and ciphertext is generated, and this output is taken as the initial vector, initialization vector for the next stage. It is the initialization vector for the next stage. You see that now you see that if the plaintext block 1 and plaintext block 2 are identical, still output will be different. So it is called the cipher block chaining mode or cipher block chaining algorithm. Again, third one is the cipher feedback mode. It is something different than previous. You see, you have the initialization vector, that means which is a random number first, and you have the key and you are encrypting the data using the key and the initial vector, and then you are inputting the plain text. You see, operation is quite different, and you are generating the output, and this intermediate output is taken as the next initialization vector. And you see the keys are here, and we are generating a. This is called CFV mode or cipher feedback mode. Next one is, which is fourth one of these varieties, that it is called the output feedback mode. What is output feedback mode? You see, we have the initialization vector, you have the key, and you are encrypting the key with the initial vector, and you are getting the output for the next initial vector. But in earlier case, you see it was like at the output stage we are taking. But here we are taking in the intermediate stage. You see, this is more randomized thing, more randomization of this. So this is called the output feedback mode. So using all these things or any one of these, you can go for generating your ciphertext. But encrypt means it is your algorithm, whatever the algorithm you have designed. Now, still now, we have talked about the sorry, we have talked about the cryptographic system. So now, nowadays you see that we have a great importance on the image processing. Thousands of images are being processed anywhere, anytime, in your social media, telemedicines, in all cases where we are sending the image for some purpose. So, suppose I am sending my angiogram to a doctor at USA. The doctor at USA has received my angiogram. Now, the doctor can ensure that it has been sent by me. Doctor can say that it is my angiogram of my heart. Suppose I have given some encrypted angiogram to the doctor, and doctor has decrypted using the key. Is it possible to authenticate that this has been sent by me? No. And that is the limitation of a cryptographic system. What is the limitation? That means I cannot ensure the non-refutation. I cannot ensure that same user has sent this for the purpose. That is why we use a separate approach, which is called the authentication mechanism, and it is also called the invisible communication. And the term defined is called the steganography. So you see what you did. See here, a leaf with three petals and a word steganography. Let's go to the next page. Here you see the word. Three petals are there, and the word steganography is just shifted towards the one petal, top petal of the leaf. So ganography. Now how do you guess? Now if I ask a question to you that can you identify this leaf? So I didn't do anything on the leaf. I didn't do anything of the leaf. So leaf three petal is there. So I can say that yes, I can identify the leaf. No issue. Next go to that. What is that? I have cropped two petal of the leaf. I have only single petal, and your this steganography has shifted more. Still I can see that it is here. So no graphy. See that it may be some other words. Now if I ask you the same questions, can you identify this leaf? You may say that maybe yes. Now let's go to the next slide. I have again the crop that's even single petal, half of the petal or two end of the petal I have cropped, and I have some middle portion. And again, only graphy is in the outside and others are in the inside. So it may be geography, it may be steganography, it may be cryptography. And again, I am asking you the same question. Can you identify this leaf? You will say that no, I cannot identify this leaf. It is a torn leaf, and you see that cropped leaf. But what is my technology? My technology says that yes, I can identify this. How I can identify this? Throw some embedded information into the image. So in a computer, I have an image. I'm embedding some information into the image, maybe in a non-vital portion of the image where it is not required. And that is called your steganographic system. And that is called the authentication, and it is called the image authentication. So we are going for encryption and we are going for authentication. Now for the authentication, normally we used to put some signature on the image. What is the signature, or what is the digital signature? A signature is a technique for non-repudiation based on the public key cryptography. So complete cryptography system is used here. That means the creator of a message can attach a code in the form of a signature, or I can generate the signature from the code or from the source ensemble or from the source information, and that is called the authentication. Normally we go for authentication in terms of a message digest. What is a message digest? That means I have a message. From that message, I am generating a fixed length code. It is unidirectional and one time. That means from the source message, I can generate the code. Reverse process is not possible here in terms of the message digest. So what is the utility of that? The utility of this message digest is that if the source message is identical, the code to be generated will be identical. If I temper the message, code will not be matched. And that is the implications of the message digest. And that normally we used to go for non-repudiation and authentication. You see that how we can go for the creating the message digest. You see the message digest is a normally one way hash function that you have some information, input information, and we are generating some information of fixed length. If this is identical, anytime I am going for an algorithm to compute this hash, it will be the identical. We have two message digest algorithm, very famous. One is MD5, another one is the SHA1. Your MD5 is 128 bit and your SHA1 is 160 bit. You see, this is the algorithm. I am not going into that algorithm. You see, there may be a forgery on that, but it is very rare. So, when we are talking about the user authentication, you see, username, passwords, one-time password. Nowadays, everyone of us using in any financial transaction, which is called your OTP or one-time passwords. You are using some public algorithms. You are using some biometric measures. So, in case of password authentications, you see that insecure authentication based on the passwords. When you are giving the password in your terminal or your system to log into the websites or the any application, you see some stars are concatenated to the right of your password. This is called the salt. Suppose you have a very good pizza, you have gone to go for McDonald's for a pizza, you have got the pizza. First thing what you used to go, you used to spoil the pizza by spreading the salt and pepper. So that's called the salt. That means noise. So who is sending these stars? When I'm authenticating in terms of my password, the stars are being concatenated by the server to your terminal, and it is being kept on the salt of the server. And when password is coming, when intruder try to access the password, it will not match because passwords are concatenated with some ghost sorts of things, which is called the salt. So, but the server password file, salt is there, salt will be eliminated from the taking the data from the server password file, and data will be authenticated. Now, another authentication systems. In your mobile authentication systems, I used to talk about this a little bit because you need to know this, because every one of us using at least one mobile, at least one smart mobile is with you. So in mobile communication system, you have the base station, which is called the BTS. We have the BSC, we have the MSC, we have the GMSC, we have the authentication center, we have the equipment identity register, home location register, visitor location register, we have the mobile switching center MSC. So a lot of things are there. The only thing mobile is your mobile, and this mobile can move, but BTS cannot move. So BTS used to provide a frequency or multiple frequency if you have seamless connectivity or 4G or 5G, or if it is a 2G, it will give you a single frequency. So on your mobile, there is a 128-bit register on your SIM. Every SIM contained one 128-bit register. So on this register, what we used to keep when you are taking first the SIM, your authentication center used to compute through the MSC. Through this MSC, used to compute the code. The code is kept to the SIM permanently, and that will also be kept into the AUC authentication center. Next time onwards, when you are switching on your mobile, You are challenging the provider that I am the owner of this. I am the owner of this mobile. You give me the signal. Sorry. Okay. A second. Now, so this challenge will be will not be acknowledged. The challenge will not be acknowledged. Instead of, response will be given in terms of the signal. That is why this is called the challenge response methodology. How this response is done? This code will be sent to the MSC and it will go to the AUC, it will compute again in terms of your credential and it will be matched. If it is matched, then one frequency or 8 frequency based of the 2G or 4G or 5G mobile, it is to give to you. This is the authentication. Now another thing is there. Sometimes when you are going to Kashmir, still now it is there that you see if you go there, prepaid mobile will not work. How it has been debated, how it is done normally. You see that when we are taking a SIM, your data is kept on the home location register. What is the home location? That means suppose you have a BSNL mobile here. BSNL mobile has two MSC, mobile switching center. One mobile switching center is at Kolkata and other mobile switching center is at Siliguri. So that's why you will see when you cross the river Ganga, you will get a R sign. That means you are not in the home. You are on the roaming. So how roaming is initiated or how R is coming? You see when you are cross the Ganga river and going to Murshidabad or Farakka. The thing is that your VLR entry is missing there. Your HLR entry is also missing there. So when you are challenging that I am owner of this mobile, that same 128-bit code will go to the authentication center under the MSC, mobile switching center. It will compute the code. Then it will see that whether HLR is there, no HLR. So it will write a temporary entry into the VLR because you are a legitimate user. So you are in the roaming stage. So when your data is written on the VLR, a R sign will come on the signal, top of the signal. You see, then R will get. So when you are going to the Kashmir, this permission is not given to write any VLR entry if you have a prepaid mobile owner. That's why if it is not written, permission is not given, authentication is not done, signal is not permitted to give to you. Though you will see that lot of signals are there, signal strengths are good, but you are not permitted. So this is another authentication systems in terms of that, and very easily you can do in your mobile operating systems by the provider. You cannot do that. Another thing is that you have the equipment identity register, or which is called the EIR. What is EIR? You see, we have three databases in mobile system. One is called the white database, second one is called the gray database, and third one is called the black database. When your mobile is in order, all credentials are okay as per your value added systems that you have taken this facility, that facility, whatever may be, it is written on the white database. And when that facility is end or the term of that facility is end, it will go to the gray database. It will write an entry to the gray database. And your suppose incoming will be on, outgoing system will be off. And if you recharge it with your credential, again it will be deleted from the gray database. So it will come to the white database. Suppose your mobile is stolen, you have given one phone call or SMS to the provider. So it will be written on the black database. That means your access of the mobile will be completely banned until your provider again give to you with some credentials and all other things, authentication systems. So using all these things, authentications are done in a mobile communication systems. That is very useful, every one of us using that knowingly or unknowingly, but these are happen in terms of that. Now I was talking about the authentication, and I was talking about the digital signature, which is being achieved in terms of the hash function. Now, sometimes this digital signature is not sufficient, because what signature? The signature is a digest. That means cows and buffaloes, they used to take the grass, put the grass somewhere in intermediate place of their body, and then take it out to the tongue, and the teeth they used to chew later on. And then they used to go to generate some reduced amount. That is your digest. And here we are talking about the same digest, which is called the message digest. So digest does not contain any additional information, that when it has been generated, how long it will be valid, and what are the content of that digest, original content. So to overcome all of these situations, a digital certificate generation is created, where we have the documents, we have the digital signature, and we have the certificates. Normally X509 is the digital certificates, where all points are valid: certificate validity date, serial number, authorities, digital signature, owner's public key, name, organization. You see, nowadays all financial transactions in any organizations and others, even individuals, you have to go for a generated digital certificate of your own from your system. We have a lot of agencies for that. So who will do that? We have a public key infrastructure. Who is the public key infrastructure? That means some people are providing you, or some organizations are providing you the infrastructure. It is the guideline, based on the guideline of the RBI. You see, that is the conflict nowadays in your Paytm. That Paytm did not follow the guideline of the RBI, and that's why from 29th of the February, that Paytm has been switched off, or that authentication system has been off. Lot of people are getting trouble to transferring the data. That because that gateway and that PKI service is not available, has been banned. So now some negotiations are going on. So this public infrastructure, you see, you have the HDFC gateway, you have a lot of other gateways, BuildX, another gateway. When you are going for a payment, you see, you have to use some gateway. That is a public key infrastructure. It is not maintained by the government of India or government of any state. It is maintained by the RBI guideline, and license are given to that particular organization. They are maintaining all these things, because when you are going for a transaction, if the transaction failed, it is being reverted to your account. When you are just giving back your merchandise to Amazon, so the money is coming back through that particular PKI, public infrastructure. Where what is the public infrastructure? We have the registration authority, verification authority, certification authority, whatever that these authorities are using all these things. It is the organizational concepts, and even I can revoke the certificate somewhere sometime. So when we are talking about the problem domain in terms of the data security, you see, you have the cryptography, we have the watermarking, we have the steganography. Steganography normally we have in a spatial domain and in a frequency domain. That means spatial domain, directly we are perturbing the pixel. What is the difference between the normal uh, cryptography and the steganography? You see, in steganography, there may be a loss of the holder, that means cover, but in cryptography, it is completely reversible. So now this formal definition of the steganography, we are talking about the steganography. It is the art and science of writing hidden message. So this hidden message written is not come just this steganographic activation is done, I think, around 2000, 2002, 3. So we are doing data hiding, secret message communications, ownership verification, and copyright protections. So secret communications, even earlier, ancient Greek and others, they used to go for this secret communications. And this was the first image of steganography, which is called the steganographia in 15th century. You see, this is very good example and very interesting example. An ancient Greek named Hysterius was fomenting revolt against the king of Persia, and he need to pass along a message security. See, securely. What he does? He saved the head of the slave, put the tattoos on the slave, and along with side with the tattoo, the message code is written. He wait for 1.5 months. Hair grows. Now, when hair grows, can you see the tattoo or can you see the code? No. So that is called the invisible visible, invisibly visible. And this is your invisible communications. It was done by ancient Greek. We are using the same term in terms of the technology, and they have gone for physical steganography. Another steganographic thing is there. You see, sometimes in 5th century BC, an exiled Greek named Demetrius wrote a warning that the Persian planned to attack Sparta. He wrote the message on the wooden backing for a wax tablet and then hid by filling the wood frame with that wax. Then give another fold of the plaque and draw some images and gifted it. The receiver thought that something inside, debolted it, mailed the wax and read the message. And third one is very interesting again. So what you see? This is a sweater. So why sweater is here? What is that? I have some design on the sweater. So if I say that, I can see that this is a design. You can see that this is a Morse code or this is some other codes which is known between you and me. That means that is a communication code. You are going for a communication code. So this is visibly invisible, terribly visibly invisible. Everyone can say that I am going sweater on by wearing this sweater on a public domain. And who is intended is reading my message. So this is called visibly invisible, and this is called your steganography. In 1942 World War II, again you see that some valuables are transferred during the war period, and that was the strategy to give the latest information or latest strategy. So tiny dots were made on the watch and write the microcodes. So watches are given, so they used to read the watch, blast the dot and read the message. This is the posture detections. You see that another. So now whatever we have seen, that these are the physical steganography. But how do we do in a digital sorts of steganography? Because suppose this is a cat or this is a tree image, but inside the computer, what is an image? This is a two-dimensional matrix. This is a two-dimensional matrix. So how do we write some secret information into a two-dimensional matrix? How we can keep the visible property of that image intact? So this is done for ownership verification. You see here I am giving some signature, and signatures are embedded invisibly. And during authentication, I am taking out the signature and I am comparing with the original signature. But problem of the holder, there may be some degradation. So there may be a special domain, there may be frequency domain steganography, or you see these are the image construction, you see. Yeah, this is the image matrix. How we see the image matrix? These are your image matrix with some pixel values. And these are all positive values, 0 to 255, 8-bit. And when you are defining the data type, it is unsigned integer, 8-bit values only. Now let us consider that how we perform this steganographic approach. How we perform this steganographic approach. Let us consider the least significant bit steganography. Suppose I am taking one Lena image and I am taking 9 pixels out of here. You see, 149, 13, 201, 150, 159, 16, 203. I have converted it to the binary. And this 1011011001 to be embedded is 365 value is. Now let us consider that this 1011011001 to be embedded on this 9 pixel in the all LSB positions. You see, on the red, this LSB position I have embedded. Now after embedding this, that means other bits are stripped off, original bits. And what are the changes? You see, when 0 is converted to 0, no change. 1 is converted to 1, no change. 0 to 1 and 1 to 0, it is change. That means you see the probability of the change is 50%, not more than 50%. You see, these 4 places out of 9. That's why the steganography is so successful. All changes are not physical changes. Some changes are, or at least 50% changes are notional changes. So how do you do that? You see another matrix. Let's consider 4x4 matrix here. And you see that we have converted to the binary. And these 4 bytes are to be inserted. Earlier we have inserted 1 bit at a time. But here, and in the LSB there, here we are inserting in the random positions. You see, here 1, then here 1. You see, like this. So embedded positions are varying. The embedded positions are varying. So you see, these are the embedded image. In various positions, multiple positions, I can embed. And what is the secret data with image? And what is the original? You see only 76 is converted to 78. And you see 65 is there. So change is minimal. You see here, this 76 is 75, 76. So like this is the methodology of the steganographic approach or approach for the invisible communication. Now let us consider a very interesting example of steganography in legal document authentication. Suppose this is one stamp paper. So any legal document, we have the stamp paper, we have some information and lot of signature. But if you think of the same document in a digital form, if you think of the same document in a digital form, then it will be some image, signatures are also some image, and it is a MS Word written document. Suppose these are the documents, text, and these are signature. Now it is transmitted, and at the receiver end, it has been changed. What is the change? Let's see the change. The positive has changed to negative, and then the maximum has changed to minimum. And you see that strong has been changed to weak. So I cannot authenticate. So how do I authenticate this legal document? It's a changed document. So what are the technique? You see, suppose you generate MD5 from this information here. Then you embed this information into this image as an invisible embedding, or which is called the invisible communication. And you just transmit the information, or you keep the data somewhere. Somewhere there is a conflict. Now what you will do? You will generate the MD5 again. Earlier I have told you that if there is a change on the base document, the generated MD5 will also be changed, which is done for the authentication. So you generate and you extract the MD5. You compare. If it is identical, that means the document is authenticated. Otherwise, document is not authenticated. So definitely you must have some PKI infrastructure for universal access of this legal document. So this can be done very easily. You see this, some of the work of our scholars. You see this gold coin is embedded on this Lena image. You see that perceptive quality is almost equal to the original. One is input, another is embedded. You see, now we can extract it and compare it. That means this image can be authenticated. You see, so we are talking about the data hiding, secure image transmission in terms of the steganographic approach, invisible data transmission, and ownership verification. This is the algorithmic steps what we normally used to do. You see, this earth image is embedded on this Lena image, and lower one is the embedded image. This is earth image is embedded on this paper. Now, why this is so successful? There is a logic here. What is the logic? The logic is that you see that when I'm embedding in a particular place, you keep that place intact and other place can be adjusted. Suppose I'm embedding 1 here, it is plus 1. So I'm putting a 0 here, it is minus 1, minus 2. So that means it's a plus 1. Again, it is coming the same thing. So embedded bits cannot be touched, but other bits can be flipped to adjust the difference. That is called the handle. So now, what we were talking about that how do we reduce the key exchange procedure in terms of the neural cryptography or neural computing, whatever we are talking about nowadays in a deep learning and whatever things we are going for, artificial neural network. So this neural cryptography is another field started in 2002. So normally, just this is a tree parity machine where we have some multiple architectures. We have some hidden layer, we have the input layer, with the output layer, we have the multiple neurons, we have various edges and weight vectors of the edge and inputs are there. You see, for interchange of the key, for exchange of the key, we are using the communication channel. Can we use the neural network for that? Here we are using the same architecture of the two neural networks at two ends of the communication, where we have one hidden layer, one input layer, one output layer. This for example. I'm not going on to details. Then you see we are synchronizing this in terms of the function. We have a signum functions. We have the rules. We are using some random input vectors. We are updating the weights in terms of the learning rules, maybe Hebbian learning rule, maybe anti-Hebbian, or in maybe random walks. And after a certain time, what will happen? The nodes, edges of two network will be identical. And what is the problem for the intruder? Intruder does not know about the architecture of the network. does not know about the number of hidden layers of the network, neural networks, does not know about number of inputs. So when we are tuning, we are exchanging a single bit. Definitely we have to use some protocol systems for that. I'm not going to details of that. So now, once it is tuned at both end of the network, then what will happen? You see, compute the values of the output neuron, compare the neuron of the both tree parity. If outputs are not equal, throw it. If it is equal, you update the values at both end of the networks in the corresponding positions. So this is this you have written on Java, and you see this is one neural network, another neural network, neural machine A and neural machine B. It is you see now unequal. In the next step, you see it is not unequal. You see number of neurons we can change, input neurons we can change, weight vectors we can change. Now you see that two networks are identical. We have used the Java, simple Java programs here. So when two networks are identical, I can use any age, values of the age and the nodes for the key. So key exchange can be eliminated. Your key exchange can be eliminated. What is the advantage? Each partner uses a separate but identical pseudo-random number. Attacker does not know the secret seed state. Increasing the synaptic depth, average synchronization will be the increased in a polynomial time. But the success probability of attacker will be dropped exponentially. Synchronization by mutual learning is much faster than learning by adopting to example generated by the network. Unidirectional learning and bidirectional synchronization we are using. And only one weight can change in the delta I equal to t, so difficult to find weight for the attacker. He has to go for the exhaustive search. In that moment, we can tune the network. So let us consider some predictive analysis for neural computing where we have, you see that nowadays we are using the CNN, RNN, multiple layers, huge amount of layers. So some networks we have tuned, and I am showing you some examples that how it behaves. Some networks we had tuned. You see that we have tuned for 120-bit key length, 192-bit key length, and 256-bit key length. And you see it takes the 4,200 cycles for 256 and 3,000 for 3,200 for 192 and 2,500 for 128-bit key. You see this is the first, I think you can see. And you see that your autocorrelation, how it is decorrelated. Then suppose I'm increasing the layer. I'm coming to the double hidden layer. The double hidden layer perceptance synchronized cryptographic technique. So after synchronization, keys are generated at both ends. No need of exchanging the key. Here you see double hidden layer. Let's say architecture. We have two hidden layer, number of input neurons. We have various learning rules. You see anti-Hebbian, Hebbian, and random. Let us say other learning rules are also there. And you see the uploading frequency. You see how is decorrelated. And not only that, you can see the very interesting feature here. What is the interesting feature? You see that we have used various architecture for 128-bit key. You see average synchronization time in a Hebbian is less. Again, if you see here, you see if you go to the synchronization time, here you see 4,000, it is reduced. I have used more hidden layer, but my time for synchronization has been reduced. You see, it was 3,200, now it is 3,000. It is 2,500, now it's less than 2,500. That means the complexity normally does not increases manifold if you go for much higher. Now you see, most of the cases we are using random numbers at both ends of the network while you are going for the tuning of the network. But here we use chaos theory. That means a chaotic equation used to generate the random seeds with the testing of the seeds at both ends. So if seed values are identical, then it will generate identical values. It will much convenient for the tuning. And you see the tuning of the chaotic based systems, here also you see it is less than 128-bit key. It is, you see, much less than 3000. For 192-bit key, less than 3000 when it was, you see, here also 4000. Now again, I have used chaos, I have used multiple. Now again, I am going for the triple headed layer. That means I am added another layer. But you see, from 4200, it has come down to 3500. You see, 92-bit, this is less than 2500, and it is around 2000. That means I am increasing the synaptic days of the system, but I am getting better efficiency. Again, you see, there are some provision that for the cryptographic system, is it necessary to tune the complete network at both ends? Can I go for a group tuning? You see, for a triple hidden layer, chaos is used, and we have used a group at the both end. And we can synchronize, we have synchronized, and we have used the team. So how the intruder will know about the group, which group we are going to train, or which group we are going to synchronize? You see, and here you see the tuning time is more because of the group tuning. But you see, the security is enormous. Possibility of the snatching of the key or compromising of the key is minimum. So these are some of the distributions and chi-square values. So I have written one book during the lockdown, for all of these things are here. You can see this reversible steganography and authentication via transform encoding is available from Springer. So is available in Amazon also. You see, these are this URL of the book. You can see the URL of the book. Yeah, this is the URL of the book. You can download it. I don't know whether it is available. It is available on the Amazon and others. Everything is written there. So now I have completed my things. So go for some question and answer. Let's go for it. Over to the organizer so that we can go for question and answer. Stop presenting. Yeah. Sanchita, are you here?
Hello, sir.
Mehboob,
Hello.
please, please.
Are you hearing, sir? Okay, sir.
Yeah.
Good
Any
afternoon.
questions from? Good afternoon.
Yeah, sir. Good afternoon, sir. As the session chair of today's program, it's my honor to welcome you
Okay.
all
Okay,
to
thank
the
you.
insightful sessions. Okay, sir.
Okay.
Thank you. So now let's delve into the questions asked by our alternative audience. There are all excellent inquiries that I am sure our speaker will address comprehensively. Without further ado, I invite our speaker to tackle these questions and provide valuable insight to our audience. So there are some questions, sir.
Okay.
So what are the potential applications of image steganography beyond data hiding, such as data watermarking or copyright protections?
You see that when you are just, I have already told this. One of the major concern is that when I am sending one angiograph of my heart, how this will be authenticated by the doctor at USA that this is from me only. So this is
Okay,
done
sir.
using
Thank
the
you.
image steganography.
Okay, sir. Thank you. One another question is come that can blockchain technology be utilized for image communication security or data security?
Blockchain, actually concept of the blockchain is quite different than image, because image does not have any node, so it's not does not contain consisting of multiple node. But within the image, among the pixels, if you consider that pixel values are node in a image, now you can concept of the blockchain for hiding the data or whatever security and authentication purpose, you can go for it, but
Okay,
the
sir.
concept
Thank
will be
you.
quite different.
Okay, sir. Thank you. And another question is there. What are the potential risks of using cloud storage for image communication?
No, it is a general risk. It is not a potential risk for the image communication. When we are communicating an image, we are authenticating using some methodology. So if you can authenticate, so there is no problem. Every one of us using that. Telemedicine is one of the major area throughout the globe. We are using sensor-based telemedicines and all other things, image communication. This is there. One doctor is there at USA and one patient is there at Kolkata, and all of the sensors, temperature sensor, other sensors are there. We are sensing the data in terms of the image, and you are authenticating on the fly. That is very important here.
Okay, sir. Thank you, sir. The question session is end. As we draw near to the conclusion of our sessions, I want to extend my gratitude to our speaker for sharing their expertise and to all participants for their engaging questions. Your active participants enrich our decisions and forest learning for all. Thank you and have a wonderful day ahead, sir.
Thank you very much.
Thank you, sir.
Thank you. I am delinking. Thank you. Bye.
Thank you, sir. Bye.